Let's now see how we can create structure with hidden attributes. Inside of our third project, we will also first create our go.mod file. Content of this file will be exactly the same like in our previous example. We will save this file and close it. We will create model directory inside of our project, and inside of our model directory we will create again person directory. Now, inside of our person directory, we will create new file person.go. Here, difference in comparing with previous example is that our name and age attributes inside of our person structure are now lowercase. So how that change our architecture? This means that our attributes inside of our person structure isn't anymore public. They are private, or in other words, hidden. Only objects, structures, variables, or functions inside of our package person can directly access these attributes. If we want to use directly values of these attributes in another package, that won't be possible. Let's now create another file, person name, in which we will create two new functions. These functions will be connected to our person structure. Inside of this file, we will create setName and getName functions, which will be connected to our person structure. Now, let's create new implementation for new variables inside of our main.go file. We want to use FMT package, but also we want to import all data from our person package. We will write zero state of our module, which will be this, and then we will add additional path on which we can find person package. Now we can use data from that package. If we try to create new variable p1 with direct path for our person structure, now in this case we can't do that because attributes inside of our person structure isn't anymore public. If we try to create p1 variable, our language will give us an error in which will be message that we have unknown field name or age. If we can't create new variable with data type person with pointer like this, then how we can do that? For this case, we will use purpose of constructor. We will access our person package, and with new function, we will create new object of person with pointer and also with specific values which we will pass to that function. We have created p1 variable with data type person. If we try to change directly values of our attributes with upper or lower cases in both of this statement, we will get an error. Then how we can change value of specific attribute? That's why we created functions which will be connected to our structures, and only functions in this case will change values of our attributes inside of our structures. If we want to change name of our p1 variable, then p1 object will call setName function and we will pass new value for our name attribute. Our setName function changed our name from David to Fred. If we try to print directly value of our attribute, again we will get an error and we will see that we have unexported or hidden field. Because of that, we created our function getName, which is also connected to our person structure. We can call p1.getName function. We can see that we cannot print directly our value, but function which is connected to our variable can do that for us. Also, now we can print whole object of p1 variable to see new modification. The real question is, what is the purpose of this kind of writing? In future, you will see many cases in which we will not be allowed to change values of our object directly, because we will have many protocols, regulations, and validations which we must apply or check or create new conditions, and all of them must be successful before we assign new value to specific attribute inside of our any structure. That's why we will create this kind of writing where we cannot assign a new value directly to our attribute, and instead of that we will create functions which will do that for us. Let's now check how we can create our architecture with hidden functions. We will create our go.mod file. Save this file and close it. Inside of our project, we will create a new directory, model, and inside of that directory, we will create directory staff. Inside of our staff, we will create a new file, staff.go. Inside of this file, we will create a new structure, staff, with 3 hidden fields, and also we will create function new, which will be our constructor for our staff structure. Then we will create a new file, staff_sector.go, in which we will create 2 new functions. In this file, we created 2 new functions, which will be connected to our staff structure, and these functions will be get and set functions for our sector field. Let's create a new file, staff indexing. Remember, after finishing implementation of each file, you must save that file before we start to write next. So if you didn't save any of your files, save them all before we start to write new file. In this file, we will create a new function, indexing, and that function will be connected to our staff structure. In this function, we will access our specific object, then we will access specific value of our sector attribute, and we will have 3 different cases for our function. If our sector is equal to 1, then our function will return us value 1.15. For second case, if our sector is equal to 2, we will return 1.25. If our sector isn't equal with 1 or 2, we will return default state from our switch statement, and that will be 1.08. So now let's talk about the name of our function. Here we can see that name of our function is indexing, but name is the lowercase, not uppercase. This means that this function we can use only in our staff package, and this function can only be reached from structures, functions, or interfaces inside of package staff. We won't be able to call this function outside of our staff package. Let's now create a new file, staff salary. Inside of this file, we will create 2 new functions in which we will set and get values for our salary attribute inside of our staff structure. In this example, our getSalary will return us value of our sector attribute inside of our staff structure. But now let's take a look more closely on our setSalary function. Our function will create a new variable, index, and that value will be equal to value which we are expecting from our indexing function. We access our S object, and then that object with data type staff will call our indexing function. We can call this function because setSalary and indexing functions belong to same package, in this case package staff. We will get value of index, and after that we will again access our S object, we will access our salary attribute, and we will assign new value to that attribute with specific formula. Let's now create our implementation inside of our main file. Inside of our import section, we will import FMT package, and we will also import our staff package as our new module. We want to create a new variable S1 as data type staff with pointer. If we try to create new variable index by accessing our S1 variable and calling our indexing function, that won't be possible because our language will give us an error that function indexing is undefined, which means that this function is hidden for all objects, variables, functions or interfaces outside of staff package, but that function can be called in our setSalary function. We access our S1 variable, then we call our setSalary function, and we passed two different values. Inside of our setSalary function, we have calling of our hidden indexing function. So here, in our implementation of setSalary, we will call our indexing function. We can see that we updated our S1 variable and that salary of our S1 variable is now 62,500. So now we understood how we can use hidden functions inside of our package, and we can call them from other functions. This kind of writing is very useful when a specific package can only call specific functions from other packages. In that way, we are avoiding all unnecessary connections and architectures which are not very useful for us. We can save our main file and we can execute our application. We can see the output of our application.